Hey guys, what's up? Welcome back to another episode of It's About Everything. So in today's video I'm going to fix this MCB or miniature circuit breaker. So the problem with this circuit breaker is its terminal is corroded. Right on the top side you can see the corroded terminal. Now everything else in this circuit breaker works perfectly. Now the reason why it was corroded because the connection was not properly made and it was heating up. As you have seen in my previous video that I'm doing some electrical work in my home to fix a few things. So this circuit breaker was attached to one of our rooms and the lights were flickering every now and then, so I started looking for the problem from our main switch, and then I zeroed in into this circuit breaker and I found out that the terminal is not properly connected. So the wire was loose and every time there was a load connected. By the way, this circuit breaker is 6 amps. There was a significant amount of current flowing through this loose connection and it starts heating up, and every time a metal heats up it starts oxidizing and it starts corroding. So you can see lots of corrosion around. Now this terminal block is not in this condition before. You can see I used my hacksaw to cut out this terminal block. It is held inside the plastic casing, only the opening from where you put inside the wire, that opening is made, and from where you tight the screw. So only two holes are there, one on the top side and one on the side, and everything else is covered. So I used my hacksaw to cut out the pieces. So what my plan is, I'm going to attach a wire. I'm going to directly solder a piece of wire that can take about 15 amps capacity wire to the terminal block. I'm going to directly solder it and then I'm going to use it because this MCB is working perfectly. Now the terminal block is attached with a single piece of wire through the internal parts and every components. You cannot see that wire on the frame, but it's right there on the left side where I'm standing. There is a small wire which is soldered, and this terminal block is actually not secured properly because it's open right now, so I need to be very careful, otherwise that wire will break. So I'm going to solder a wire which is about 10 to 15 amps capacity, which is triple the capacity of this circuit breaker. So here I'm going to use a little bit of soldering flux and I'm going to pre-tin the surface with a little bit of solder, and then I'm going to tin the wire as well, and then I'm going to solder both the wires together. So I will not recommend anybody using an old circuit breaker because the circuit breaker might have the internal components might have been damaged while it was operating previously, and it might not work when you reuse it. Now right now I am sure it is okay because I have tested it. I will show you the test. I will test it again and I will show you how I have tested it. Well, basically testing a circuit breaker is, well, just by shorting the terminals and see whether it pops or not. So that's the only way of testing a circuit breaker. So I'm going to test it after I have soldered the wire. So as I was saying, I will not recommend anybody reusing a circuit breaker because the internal parts, the functionality of this circuit breaker might be compromised, and when you reuse it and at the time of overload or short circuit it might not trip and this might cause a fire. So I will not recommend anybody using an old discarded MCB. So I have already replaced the MCB with a new one, but still I wanted to keep it and reuse it because it was still okay, it was functioning properly. The only fault was the wire. Now why the wire was not connected properly, because the screw that was given on the top side, it was not tightened and that's why the connection was loose inside. And every time there was a load, this one is a 6 amp circuit breaker, so every time there was a load of 3 amp or 4 amp, the wire is poorly connected and it heats up, and as it was heated up, it started corroding the surface, and it created some sort of resistance, because as it was corroding, it was producing it was oxidizing. There was an oxide layer which was actually making it to corrode, and due to that oxidation layer, it was heating up more because it was creating resistance, and it was heating up more, creating more corrosion, and that's why the entire front section was started to melt. But this plastic that was made, that this MCB was made with, was burn proof plastic. It will not burn, it will melt but it will not burn or catch fire. So that's why the pieces that I have used a hacksaw to cut it off, that portions were partially melted. So as you can see, I have pre-tinned the wire and the terminal block, and I'm going to bend it in an angle and then fit it, and then I'm going to test it. So before using any discarded MCBs, make sure it works. So now I'm going to solder the wire. Okay, so as you can see, the wire is being soldered. Now this terminal block is made out of brass and it's really big, so I need to hold my soldering iron for a longer period of time to heat it up so that the solder joins properly. Okay, so here you can see it's completely joined and it's super solid. You can see the terminal block is moving a little bit when I am pulling the wire. That's because it's not fully secured, and I'm going to secure it using some epoxy compound. But before securing it with epoxy compound, I'm going to test it. So I'm going to directly short it out and see whether it turns off or not, whether it trips or not. And I will not recommend you doing that if you are not familiar with electricity. If you are not professional in this field, then I will not recommend you doing that. Now if this circuit breaker fails, it's a 6 amp circuit breaker, and if this circuit breaker fails to trip, I have another circuit breaker down the line which is 10 amp, so that will trip for sure. So I'm going to connect the wire to a 220 volt supply, and then I'm going to directly short it. Now I haven't done this before, so I'm not sure how much electrical spark it will create, but when I bought this circuit breaker, the shop owner told me that it trips really fast, and before creating an arc it will shut down the circuit. So today I'm going to see whether it does that or not, whether it trips or not before creating an arc. So this is how I'm going to short it out. Now let's turn it on, it's live. Okay, so let's do it. Okay, so you can see it just tripped and there was no spark at all. So it is working just as it was said, just as I was told by the shop owner, that it will trip first without creating an arc, and it does it very perfectly. Okay, so now I'm going to use epoxy compound, which is M-Seal, and it's pretty popular epoxy compound available in India, and it gives a very good insulation from electricity, so I can use it. And I will cover the entire terminal block with M-Seal. So the process of mixing it is taking equal amount of this epoxy compound, part A and part B, hardener and resin, and then I'm going to properly mix it. Now I've used a little bit of talcum powder in my hand so that it does not sticks to my hand, and then I'm going to use a technique that is very simple to do, and it's fast for mixing M-Seal or any type of epoxy compounds or epoxy putty. So here you can see I am rubbing my hands in a forward direction and then from side to side. So what is actually happening inside is, when I am rubbing my hand in forward direction, I am creating a rope of the epoxy putty, and when I am rubbing my hand from side to side, that rope is converted into a ball, and every time I'm repeating the process, it becomes a rope and then it becomes a ball in my palm, and thus it's completely mixing. So this is the fastest way I have developed myself to mix epoxy putty or epoxy compound, and you can see it's thoroughly mixed. So this is the process. When I move my hand in forward direction, it becomes a rope like formation, it becomes long, and when I rub my hands from side to side, it becomes flat and turns into a ball. So this is how epoxy compounds should be mixed. It's fast, easy. So now I'm going to apply a little bit at a time, and I'm going to cover the entire terminal block. Okay, so here you can see I've applied all of the epoxy compound around the terminal block. I've just left a little bit of the soldering joint open, so that if it requires in future to change the wire, then I can do that. So here you can see I took some talcum powder again, and I'm applying it on the epoxy compound. That is because it will not stick to my hand, and I can easily use my finger to make the surface smooth as possible. So this is another technique that you can apply if you are making something with M-Seal or epoxy compound or epoxy putty, any type of epoxy putty. Use a little bit of talcum powder and it will not stick into your fingers. You can easily smooth out the surface just by following this process. So right now I can say it's completely done, and I will keep it for drying. After about half hour to 1 hour, it will become semi-solid, and after about 2 or 3 hours it starts become fully solidifying, and if I keep it for 12 hours it will become rock solid, just the same as the plastic. And one thing about this M-Seal is it does not burn as well. It has insulating properties and it will not burn. It's fire resistant as well. Although I'm not sure about the fire resistance that I said about the epoxy putty, that whether it's fully fire resistant or not. So here you can see it's completely covered. Now I leave it to dry, and then I'm going to use it somewhere. So this was it guys, I hope you enjoyed this video. If so, then hit the like button and share it with your friends, and if you are new in my channel, then hit the subscribe button and Also hit the notification bell right next to it so that you can receive updates for my new videos that I upload. So thanks a lot for watching. I'll see you soon. Have a nice day. Take care. Bye bye.